Good evening and welcome back. In this particular session, we'll be looking at another library supported by Python. It is called as the Pandas. So basically, the Pandas will be used for data manipulation. So just get some idea about Pandas. So what is Pandas? As I mentioned, Pandas is a library in Python basically used to work with huge data set. Now, when we collect the data set from various resources, always there will be a chance that the data set is supposed to be cleaned before you go into finding the information in that particular data set. So Pandas actually supports that. And Pandas also does help you in exploring the data, and mainly you can manipulate the data as per the requirement. So Panda actually stands for panel data and the Python data analysis. So altogether it's called as Pandas and originally created by Wes McKinley in 2008. So the Pandas basically is a tool which we basically use for the data manipulation purpose. So in addition to that, it also allows you to follow some of the mathematical procedures as well. And normally, as a first step of uh, data pre-processing, the pandas comes into picture and in data science. All right. So that's actually the introduction part. Now, basically, we'll look at what this pandas can do. So normally it's called as a cleaning of the data. Any data which is a messy kind of thing, right? We can try to we can try to manipulate. So normally, some of the things that pandas can do is, if you want to do a mathematical analysis such as correlation, cross correlation, auto correlation, right? What are the correlation between various columns of your data set, right? If you want to check that, we can do this. All right. So what's we can do the analysis part. So in addition to this analysis, you can do the cleaning, explore, manipulation, many things can be done. We are going to look at that in detail. Now, so basically pandas is built in. All right. So when the pandas is built in, I can actually import, and the common alias used here is the PD. So import the pandas as PD, right? And whenever we bring the pandas into the memory, normally we can check, okay, that is PD dot underscore underscore version underscore underscore. So that actually tells you which current version that we are using now. So looking at the basics of pandas, the like other modules we have studied, or other libraries, each of the library is capable of bringing in its own kind of data type basically, right? So pandas also has uh, two types of its own data type. All right, so the two types of data that we basically have here are, one is called as a Panda series, and the second part is called as Pandas data frame. So we are going to look at these two in detail in this particular session. So we'll look at the different data types supported by Pandas one by one. So this is called as a series. It's assume that the whole Pandas works on a table. So if you have a tabular data set, try to recall the very first session that we had. In the slides, I showed you various types of data, various data formats in which we may face whenever we try to collect the data from various resources. And the most common one was a table, right? Since the highest phased data is of the tabular type, right now we are looking at Pandas because whenever a tabular data comes, we should know what we can do. So keeping that in mind, if you have a table with you, it is made up of several rows and several columns, out of which each column is of the same type. For example, if you say the column heading as name, right? Under that particular column, every entry will be text. Every entry will be a string. At the same time, if you say the column heading as year, so what do you mean by that? Every number that comes in that column is of the same type. So you see, every column of your table is called as a Panda series. So as the name suggests, Panda series is like a column of a table, right? It can be considered as one-dimensional array and holding the data of any type. You can have any type of data as a Panda series, but in a series you have the same type. All right, so let us try to look at that. Right now, how to create a Panda series, we'll try to understand that. So let's say A is equal to, let me try to create a list 1, 5, 7, 2. And what I do here, I'll create my series equal to, you can try to create a series using the following technique. It's pd dot series. This is the function. We just have to tell that, okay, convert this into a series and inspect my series. So as you can see, it's an inspection. If I try to print, you will see a different view. Right, you can see that, right? Inspection and the printing is actually generating a very much similar one. So it actually added the index. Automatically, it actually added the index, right? If nothing is specified like this, here you see that I have not specified anything. So when you have not specified anything, the values are labeled with their index number. Example, first value has an index 0, second value has an index 1. So this is what we see now, right? The same thing is being printed up over there. Let me show you that same thing. Right, but right, how do you check what's the first value? You can address that by using the index value. So you can use 0, you can use 1, you can use 2, you can use 3, etc. If you want to check that, you can use like this. That's my what's called as my series of, say, 2. It says that 7 because you're trying to look at this 2, right? 2 is the index, value is 7. Okay, so that's how it is. But if at all you want to create your own index, right? I want to say that, okay, right? I want my own indices to be present. That's also possible here. I just have to use an argument called index while creating the Panda series, right? So if you want to create a label as per your requirement, we will be doing this. So let me go back. Uh, I'll modify. Okay, I'll modify the same thing. This is A, but I need to specify because the A, right, actually has how many entries? I think 1, 2, 3, 4. So I need to specify 4 indices here. Index values, index is equal to, you will enter in the form of a list, specify what you want. Like say the first number I want to see, it's A, comma, second one, B is the index, the third one, C is the index, and I have a fourth entry. That's why I call that the D. Right? I do that and I print. Now you see that instead of this over here, you have 0, 1, 2, 3 as index. Here, whatever we have specified, like A, B, C, D, that itself comes into picture. Now you see, if you want to check, you cannot enter 0, 1, 2, 3 here because the index has been changed. So you will write the my series of, you need to enter a specific one, let's say B, then it actually prints. Okay, now this actually resembles pretty much to our the dictionaries. So in the sense, if you have a dictionary, can I convert into the Panda series, right? Just to answer that question, let me take up one example over here. Like if you have a dictionary key value kind of relationship, right? We'll try to convert that into the Panda series now. So for example, let me create that. Let me say variable that is equal to D1 colon some number. Let me write D2 colon 500. Let me enter a few numbers here. This is D3 colon, because I'm trying to create what? It's a dictionary. All right. So this is a this is what is a dictionary. Now my series, I'll try to change this now. So this is equal to pd pandas dot series of, you can directly pass the dictionary as it is. That's okay. I'll try to give a name here, such as I identify that this is a dictionary. So I'll give a name my dict. So I create a dictionary and I pass the dictionary over here, and you can see that, right, it actually converts that into a series. So check, inspect. So this is pretty much possible. All right. Now, if I actually have a dictionary like what has been created over here, but I don't want every entry in the dictionary to be converted into what is called as the Panda series, right? So if this is right, converting, you are not completely considering the dictionary, you are considering a part of the dictionary to be converted into the series. Okay, so to do that, you write a my dictionary. Till here it is fine. Only specify what index you want. Index equal to, look at the key values from the dictionary. Just mention that I want D1. Oh, I want D1. I don't want D2. Let me write D3. So this has to match, right? Whatever you have here should be present in the dictionary that you have created. If you don't have, it will be an error. So check that. Now you see you have only D1 and D3 present over there. So this is one type, one of the data type that is present, that is supported inside the pandas. Panda supports only two things. First one is series, that is done. Now we'll move to the second data type that is supported inside the pandas. Okay, so now right now we saw that it's only one column of certain table. That is what we have called it as the Panda series. Now what is the other option? Other option is considering the complete table, right? Only one column, add another column, it will be a complete table. So that means, let's look at an example, right? So it's actually the data set in pandas are usually multi-dimensional tables called the data frame. So it's actually, right, series is a single column, data frame is the complete table, right? Let's try to create that now. All right, so let me try to create the data. Right, again I'll try to create this as a dictionary. So I'll try to write my dict is equal to, let me try to create this. So saying that I'll write, say, calories, the key, and this has the numbers 400, 500, 600. That's the first thing. That's the first key value pair in the dictionary. Then I'll write, say, duration of my workout, maybe. So that means I'll just write in maybe numbers. So this is a, say, 30 minutes and maybe 45 minutes and maybe 55 minutes. Let's see. So this is what is my dictionary. All right. Now this dictionary is directly converted into a data frame. My I'll write DF, my data frame. First, let me write my data frame is equal to, the command used here is pd, the data frame, pd dot data frame of my dict. All right, so dict gets converted into the data frame. Now let's visualize our data frame for the first time. Okay, so let's try. So you see that it's a neat table. I'll also try to print, right? Print and inspection remains pretty much same here. So if you print, this looks like this. You see that you have not given what are the index values, correct? Because of which I'm not able to see, right, the index value. By default, index value will be like this. Okay. Right. Now, first thing, right? How do you access the data? Previously, we know that I can access the data in a series by using its index. If you know the index, you can access. Right. Now, assume that you know the index. If you say the index, I need to see that the 430. Okay. So how do you identify, right? How do you access the data? So to access the data, let's try accessing row wise. Okay. So reading the data row wise. This is our first step. So you use a keyword attribute called LOC, right? So that is, I think I have my data frame. That's what is this. So let me try to use the same thing. My data frame dot. You have to use location, LOC, and you say that which location you want to check. I say location number 1. It sees, it's going to say that in location 1, the calories is going to take a value like 500. The duration is going to take a value of 55. So that's what you see here. Right? Now the point here is that what you are getting actually a column. This is a Panda series, right? So calories is 500, duration is 45. Means what, right? This is the key value, this is the index value, this is the value, this is the index, this is the value. So actually whenever you try to read a row of the data frame, the result is a Panda series. All right, so that's fine. Now I can actually go with multiple values as well, correct? So that is, I'll go with the my data frame dot. I need to find the location because I need to go to the specific rows. So you will enter the rows like 0 and 1. See, you see 0 and 1 from that. You can write 1 comma 2, right, as you want. Now you see, when you use this technique, right, the using the location, and if you use a square bracket inside to specify those indices, you will get a data frame itself as the answer. So two things to understand. If I directly write the index, the result is a series, right? Inside that, if I use a square bracket and I enter those indices, right, you are going to use them. You are going to get the answer in the form of a data frame itself. Very important. Okay, then let's go with the, so far the indices are automatically named, right? 0 and 1, etc. automatically named. So already we have seen that if you are using the Pandas series, you can specify the names, index, whatever you want. Correct? Now let me go back. I already have my dictionary available here. I'll copy that once again, right? And this is the dictionary. I'll convert the dictionary into the DF, okay, data frame. I'll call it as my DF, my data frame is equal to, it's the PD dot, sorry, PD dot the data frame of, specify from where you are actually collecting this data. Data should be coming from my dict. Okay, but if you simply use this, it actually puts 0, 1, 2 as the index values. But I don't want that. I want my own index values to be present. So I use an argument called index. Specify what you want inside the in the form of a list. So this is D1 first row, D2 second row, and D3 the third row. At the end, I'll inspect my data frame. Right, now you see the difference. Earlier we had zeros and ones as the index because that's a default thing, but now I can see that, right, I'm getting D1, D2, D3 as I suggested. Now if at all you were having no idea about the index, that's a default index, you were used to, right, use the LOC, right, to, and after that you used to enter the 0, 1, 2 or something like that. Okay, but now you see, I know that there are names. If you know the name, then how do you locate the name indices? So you again use the LOC itself. Already you see, you already use the LOC once, right? That was to locate specific index, default indexes 0, 1, 2, etc. We knew that they were default, but now you see the names are given. So let's try to locate. Okay, so that is my data frame dot, you use LOC once again, right? But you see, you'll specify like D3. So as a result, since you're asking only D3, you get a Panda series. Okay, so that's a result. And if at all you want to read the files, right, from into a data frame, if at all you have, right, any other forms of files, you can actually read that, right? So reading the files we'll see slightly later. So mainly what happens inside the pandas is that you collect your data, put it in a file, and when you want to do the analysis, cleaning, manipulation, etc., you bring that into the computer. Okay, so one of the main data type that will be present in our in the data science uh, under the data science code is the it's CSV file. Okay, it's a CSV format. Let me give an example. Okay, so let me share you one file to you, right? You please share it. Sorry, you please save it in your this thing, and maybe you can use it at a later stage, right? So there is what is called as data.csv. I shared you one file, right? That is called as data.csv in the chat, so you can collect it. It's a very small file, but anyway, I'm using that file in the program now. So let's use it. So it's there in my computer memory. So the first thing normally we should know here is that how do you read? So reading the one of the very common format in the data science is the comma separated variables, comma separated values, right? That's also fine. CSV file, right? So let's say that we have a file called right, data.csv. I'm bringing it to my computer memory. So df, this has to be present in the current folder. Then I can mention its name. All right. So that is pd dot read underscore. This is an inbuilt function. You can read it directly. Just mention what's the name. Name is data.csv. Okay. Then I type df. I can see this. So it says that you have a huge data set of 169 rows, 4 different columns. Okay, if you want to print everything, you see that it didn't show the complete, what do you call, data frame. It actually skipped in the middle. There are dot, see that. But if at all you want to visualize everything, right? So I'll write. If you want to see the complete data frame, I'll use the df dot to, it's called as to string. It will display everything, but it may not be in the same form. Okay, let me go with the print, because I didn't ask a print, right? Maybe that's the reason why it is displaying at random. So you see that, yes, the complete 169 rows and 4 columns are displayed over here. It's optional. You can see like this, or if you just want to have a broader view of what it is, right, you can just use this. Just check df or print df should work. Right, that's the first thing that we need to know. How do you read the data? Okay, then let me share you another file that is also required for us. It's called as a JSON file. Okay, again, this is another very very common data type uh, in the data science. So I want to show you how to read this. All right, so let me share another file, that is data.js. Again, download and keep it with you so that when you run the code that I'm going to share for the day, right, this file is required. All right, so let me show you how to read a JSON file. Again, JSON is another very important data format. All right, so so next is to read the JSON file. So what we do, again, df is equal to pd dot read underscore JSON. Then you mention the name of that file, right? So it is data.json, right? And as usual, I'll first enter only the df. That's the error. Let me check. Expected. Let me check. Just JS. Let's check that. Yeah. So because the file was just JS, a mistake. So df is there. Again, you can try to write the same thing. If you write df dot toString, you can print the complete details of that. All right. So that's the fundamental idea about this. Now, what are the options you have to view this? Already I have a data frame with me, right? The first thing is that you can visualize only a part of it, right? So that is the visualization part. So I'll try to see, right, a part of my data set, because I don't want to see the complete data always, because normally you have 10,000 rows, 15,000 rows, and so on. So for that purpose, we have a method called head. df.head, if you use, df is your data frame, already it is there. If you press like this, you always see the first 5 rows, right? This is 5 rows. But if you want to see more than that, let me say that I want to see the 10, not just 5, I want to visualize 10. Right? First 10 rows, if you want to visualize, what do? Right. So in such scenario, right, we will try to mention that how many rows you want, right? So df dot head, right? Okay, this is not 5 rows, this is the first 5 rows. First 5 rows. Then if you want to visualize any other number, then you enter that df of 10, right? That makes, that shows you the 10 rows. Right? So df dot head. Very similar to the head, you have tail. Last 5 rows. So that is df dot tail. See, last 5. Again, I can do the same thing, df dot tail of say 10. It shows you the last 10 rows. Since I mentioned 10, it's going to show you 10. Right. Then the next information that you can actually get is called as what else? What other information I can get instead of by just looking at this head or tail? I'll be able to see a part of that. but I may not get any other information than this. For that purpose, if you want to see any other information, you have a function called method called info. So that is df dot info. So it actually tells you that, right? It has 169 entries, 160 0 to 168. Okay, and that's what is a index, right? Then the data columns are, there are totally 4 columns, 169 rows, 4 columns. Then name of each column and what type of data it is. It actually tells you that, right? So column name, duration, there are 169 non-null. Every number, every value, every place has a number, has a value. So there is no null value. Okay, so it's of type integer 64. And the pulse and max pulse is also same thing. But you see the calories, it is float 64. I can identify that, right? So look at the last column, right? That is calories, it's a floating one. Right? If you have empty value, right, nothing is written over there, then that is called as a null value. So it says that non-null, there is no null values in it. So we'll discuss about the null value soon. Okay. Then let's go ahead. Right here. Fine. So let's look at what is called as the data cleaning part, right? We have the data, in either of the two formats that we already have seen, right? So what are the two different types that we have seen so far? It is, right, one is called as the Panda Series, and the second one is called as the Pandas data frame. Okay, now let's let's bring our data set into the computer's memory, right? Just give me a second, I'll share you the data set. All right, looks like we have our data set with us. Let's try again. So I have the data set, which is called as my data.csv. Yeah, now we can see that we have, right, so many columns with us. So there is unnamed. I think I can, oh, I can remove that. Just a second. So it says there is an unnamed column. I can actually delete that. All right, now let me read it again. This is the data. Yeah, now you see we have 1, 2, 3, 4, 5 columns. And before going further, let's look at the information once. df.info. Right, you see here in the date 31 non-null. So totally there are 32 entries, out of which you have one null value. That's what I come to know. And in the calories, you have 30 non-null values. So that means what? I have two null values in it, right? So let's just look at that, right? So df dot, if I want to see the see those values, right? I'll look at, anyway, I'll look at the toString format. So df dot to, okay, I'll print df dot to toString. Now I should be able to see if I have a null value. Yeah, you see here there is an NaN, that is not a number. Not a number in the calorie, another not a number in the calorie. So total overall, I can see that yes, this is what is the case, right? This is what is the complete. Now I want to remove, right, those not numbers. So I call the new df. This is equal to, in the data frame that's already we have created, I think we called it as df itself. Yes, df dot drop. The function is drop na, right? So I get a new data frame here. So now I want to see that, okay, print the new df dot to string, right? So when I do that, I can see that this is a new df. You can see there were 31 lines earlier. I should have, right, those NEs are not there now, right? So those NAs have been eliminated. So that is one method. But you have another option called, in the original, what you call, this is something like I'm creating a new data frame, right? New data frame. If you look at the original DF, it is still having the same, right? The not a numbers, right? Let's verify that. So DF, okay, print df dot string. This should show us the NA, right? You can see NAN, 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 etc. So you can see here the line number 18, which was having a not a number, it is actually removed. Like that, wherever you had those not a numbers, they are removed here. So 21, the 22 is removed, 23 is there. And somewhere here, line number 12 or 9, 10, where was it? 1, 2, 3, 4, 5, 6, 7, 8. Somewhere I had another not a number. It was in line number 18, 22, and 28. Okay, so the 22 is not there, right? Correct. So we can see that the line number 22 is actually removed here between these two, and even the 28 has been removed in the earlier case. But in the original data frame, it is still there because I didn't touch that. What if I don't want to copy to a new place? Because originally my data will be very large data. So it might take, say some 1 GB of space in my computer. If I create a new data frame, it takes 1 more GB of space. So I don't want to do that. In that itself, can I remove, right? If you want to change the original data frame itself, I want to do the change in the original data frame. I don't want to create a new file. If you want to do that, yes, in place equal to true is the argument that you are supposed to say. So original data frame is df itself dot drop na, then in place equal to true. And now you check this. So print the df dot I'm not printing the new data frame now. I'm printing this itself. So it should be very clear that I should not have line number 18 in this, 22 in this, and the 28. It's actually the df itself. So since you mentioned in place equal to true, right, we can see that. Okay, so that is one option, removing that. But it may not be true, because some of the times, sometimes what I have seen is that while doing a data science project, you will get some of the columns, right, where most of the data points are NA, right, not a number. But if you remove the rows, you lose the complete data set. Almost everything will go. So there is another option, you replace, right? You try to fill with something. Whenever you miss a particular value, right, you can actually specify what you want to fill, right? So for example, there is a fill NA option. Let me read the data once again. df is equal to pd dot read csv of that file, which is my data dot csv. I read this, and df dot info, just to confirm that I read the same data once again. I should have some missing values, not a number. So you see that, yes, date and the calories have something missing, right? So to fill that, right, I can say that in this df fill NA, fill the missing numbers with the value 130. Then you say in place equal to, do that, and then you check df dot info. The missing values above should be filled now. Now you see everything is here. I have, right, the 31 non-null, 30 non-null. Now you see everything is filled. All the 32 are non-null. Okay, then while doing this replacement, you have an option to specify that. I can specify a column name. Do this change only to the following column. I can specify that. All right, so for that purpose, let me copy this and let me paste. I read this. I know that it's a missing data. There is a missing data in it. And what I do now, I'll say that only do the change to the calories. Okay, so that is df. In that df, go to the column, write the column name exactly as shown over there, CALORS. Go to this column, and in that column, fill NA, right? Certain value, say maybe 130. I specified 130 already, so I'll say that in place equal to 3. Once I do this, I'll check the df dot info. You can see that, right, the date is still having a not a number, but the calories, it's filled. Okay, then it's not only that, I can do a lot of more things while while replacing the values. You can actually select, this is the best method according to me, right? Rather than dropping and rather than filling it with some random values, you can do this. This is much more valid. Either you can use mean, median, mode, right, etc. Whatever you want, you can use it, and you can try to fill that. So I'll go back and I'll copy the same thing, and this is how I read. I know that, yes, I have the missing values. Now to fill, first I calculate the mean value. That is, let's say I go to the calories and I calculate its mean value, right? So that is in the data frame, go to the particular column called calories, and in that calculate mean. This is the X value. Now go to the df and look at the calories column and fill that NA numbers, not a numbers, with this X value, which is the mean. Okay, and in place equal to true. Now what I will, I'll do the same thing. Now actually I would like to see that result. Wherever I had a not a number, I'm supposed to get the mean value being replaced. So for that reason, try to print the df dot toString. So I think the line number 18 was this. So we can see that 304.49, another 304.49 here. So those are the two values which are filled by this. Okay, you can even do the median here. You can even do the what do you call the right the mode, etc. can be applied. So only replace, right? Like I'll just write use median or mode instead of mean, right? You can use this. So that is one way of doing the cleaning. All right. What if you have a wrong format, right? You actually have, right? You might have something wrong type of data that is present all in this data. Okay. So if at all you have something like that, I should be able to deal something with that. All right. So what I do, I'll try to load this data again. I'll go back. So right, how do we deal with the wrong format, right? If you have a wrong format in the data, this is what we are trying to do. Okay, so this is what we are going to check. Let's load the data and let's check the data again, because in the original data there are some wrong formats as well. I don't want the info, I want the, okay, print the df dot toString. Now I'll show you some of the wrong formats. Yeah, so you can see that there is NaN and there is a number. This is wrong format, correct? So I just want to check that, right? How do I correct this, right? If I want to correct that, for example, this is a data, sorry, this particular column where I'm looking for the correcting the format is a date column, right? So date is another valid data type in Python. So you have standard methods available to correct that. So there is a particular method to correct the date. So this is how I do that. So I have read my data, it is df. Now go to the df, that's a data frame. Is it dot? No, I want to go to a particular column called date. See, there is a column by the name date. I'm talking about that particular column. df of date should be equal to, and in a sense, in that particular complete column is equal to pd. There is a function called to date time. To date time, in the sense, if there is a mistake in writing up, it will actually try to correct that. So df date. Now let me verify what exactly happens here. It tries to correct as much as possible. row df to string. Oh, let me check what I made. Did I make a mistake? df of date is equal to pd dot to date time. It's correct, right? So what's the name? It's df itself. It's correct, right? Let me check. Let me check the error once, like to understand what it says. It says key error called date. Date only, DATE. Looks correct. Let me reload that once again, because the info says that it's not just date. Date is somewhere here. DATE. I think there is a space before that. Maybe that is my mistake. I will read it again. Yeah, I don't know what happened. It's correct now. So you see, actually, where there was a mistake earlier, the mistake was in this line. You see the line number 24, there was some mistake. Now you see that the line number 24 is corrected. But this, when you say that there is not a number, it has no idea what you need to put. Okay, so now in such cases, I cannot put a random date here. Since the date is, you are not able to trace that date, you can remove a particular row. All right, so you can actually go to a specific column containing a specific not a number, and you can try to remove that. So I'll show you that how to remove this particular row, right? Because I can say that go to this date column and find out where there is a not a number and remove that particular column. I can actually specify that. All right, so that is possible here, right? Again, by using the drop NA method. So that is, I want to go to this data frame and I want to, sorry, drop, I want to perform the not a number, but you see, you need to specify a, what you call, a keyword using subset. It actually helps you out to specify which particular column I should look for, not a numbers. So for example, this is date, comma, in place equal to true. Make this modification in place. Then let me print. Even the info is fine for us because I don't want to see that. I'll see that that particular row has been removed. That's all. Okay, so df dot info, right? Because I didn't touch the last column, so I still have that not a number present over here, right? You can actually subset the date and you can specify. If you want to touch only date, this is the best method. Okay, don't touch this because the other method we already have seen how to, right, fill that out. Right, so let's see how to modify the wrong data, right? So in the sense, you can, when you go to the data set and when you check that, you might find out that there are something which is missing, something which is wrongly entered. For example, you see here, this could be line number 7. The duration is entered as 450, which is definitely not case, because all other values are 60, 60, 45, 45, 60, 45, 35, etc. like that. So that means in the row number 7, right, I can make a correction, right? So it will never go to 450 because all other data values, we can see that, right? We can actually, right, modify that. So that actually comes under what is called as the replacing the values, right? If there is a mistake in this, I can actually replace. So replacing the values, right? So let's try to do that. How to enter? So enter df. I know that the location, I know which location it is. What is that location? If you see carefully, sorry, if you see carefully, this, I know the index value, right? Index value is 7, and it is duration. Go to 7th row, and the column name is duration, right? I can specify df dot loc, because I know that loc can be used to identify the location. 7 comma duration. This means I am reaching a particular cell, replace it with 45. Okay, I do that, then I'll go for, I want to visualize this, or I can write this df. It's a 7th one, so I can just see that. So I can see that here. So just enter the first 10 values. So 7th one should be, right? You can see this was, right, something like 450 in the earlier case, and now this becomes equal to simply 45. So you are able to update the values as and when required. Right, then actually I can make some more changes depending upon what you call. So if you see this actually, this is not a suggested method. Why? Because in this case, I should know that everywhere, right, I can see that, right, those values which are actually present, I should know its position. But it is hard to know their positions in a huge data set, in a very huge data set where you have 1 lakh rows and say 4,000 columns. It is very hard to, right, go with this kind of definition. Now, one thing that we can do here is that you can put up a condition, right? So whenever we have a huge data set, right, I can actually put some conditions, and I can try to, right, modify them accordingly. For example, let me check my data set once again, and right, I know that the maximum, let me load it once again. Okay, let me load this once again. So I can see that, yes, my 450 still exists, right? I can see that the duration is maximum duration is 60. So anything more than 60, I can put a condition over here, right? So I will check the index. So there is a method called index, right? So this is the method, right? So for, I can put a for x in the df dot index, I'll put a condition if the df dot location, then is specify x is the location, and I'm looking for duration, right? If this value is say greater than 60, I have only one value which is greater than 60. I know that the complete column has maximum value 60 itself. So if that is the case, I can simply say that make a change df dot loc x comma duration, right? Make this is equal to any number you say. Highest is 60, so replace it with the highest number itself. Okay, I'll come out of the loop and then I try to check the df dot okay, let me try to write the head itself, and I'll write the first 10 because seventh one is expected to change. So yes, you see that the seventh one is now 60 because this was 450, which was out of the case. Maximum is 60, let me assume. So if it is more than 60, you replace it by 60. All other numbers will remain as it is. Okay, you can do that. Or the other option is you can use even the for loop for removal. Right, I'll show you that now. Let's check out how do we remove them. So how to remove these rows? Let me paste the same part of the code. Yes, and now my code is just like this. I'll go ahead with the for loop in once again for x in the df dot index. Df dot index will be all the index values starting from the minimum, that is 0, till the last number, that is 31. Right, I will check if the df dot location x is the index and a particular column that is equal to duration. I'll check that. If that is say more than 60, simply drop df. There is a function called drop. You can use it. Drop that x, comma. In the sense that particular row you are going to remove, and you will write in place. In place equal to true. Right? So after this, let's check that now. Df dot df dot head plus 10. I should miss number 7. Yeah, yes, it's happening here. You can see that after 6, no 7 have it. Then the next common thing that we face is called as identifying the duplicates. This is one more common problem, right? Normally we face it, right? Whenever we discuss, whenever we try to solve, right, certain problems in the data science related data sets. So let's see whether we have a duplicate here. Any duplicate? If I have a duplicate, I can try to. Yeah, see here, line number 11 and line number 12. Right, I can see that we have a duplicate. right? It is always possible to identify duplicates, and right, you can try to drop the duplicates, right? So let's try to look at the duplicates now. First, let's try identifying the duplicates, and let's then discuss how do we, right, modify them. How do we eliminate? So this is discovering. What do you mean by duplicates? Yes, multiple rows have the same values entered, and if at all you have a duplicates here already present, we can do this. There is a method called duplicated. So if it's duplicated, say line number 12, it says it is a duplicated one. It is a duplicate of some other row. It will not say that it's a duplicate. So if you have duplicate rows present, you can simply, you say that, okay, I came to know now that there is a duplicate one. So I can say that dot duplicate, and I need to say that in place equal to true. So df drop duplicates, and you say in place equal to. All right, then I will also check for this just to verify that whether it is removed. Df dot toString. Only the duplicate needs to be removed, right? So I don't see a line number 12. After 11, we have 30. Right. Then one more, the very important aspects of the pandas is that you can try to find out the various relationships among the data set. Okay, so all right, so I'll load the data first. Okay, let's look at this. So we'll try to find what are the various relationships. Right? What are the types of various relationships that we can have here? Right? We'll try to load that. So first, let's load the data. Df is equal to pd dot data. Is it data? Sorry, my mistake. It's read CSV. Read CSV of the particular one, data CSV. It's read now. So in this df, I want to go with the correlation function. Okay, so the correlation function is a table with, you can see a lot of numbers. All of them are something like the real numbers, right? Actually, this particular, these values entered here, right, they represent the relationship between a particular column with the other column. So you see here, for example, duration versus duration, it says 1. And I see that 1 is the highest number that is present over here. Again, I might get some negative numbers also. So since the positive highest number is 1, in practice, the negative number that actually, right, the lowest number that comes on the negative side is -1. -1 to +1 is the range. Right. So, if at all you try to find out this, okay, let me try to give a note here so that you will be able to understand the relationship in a very good manner when we go back and check this again later. All right, so this is the result part, right? Whatever we got here, we are trying to understand that here. So in this case, if you see a 1, that means there is a 1-to-1 relationship. It means perfect correlation. In a sense, both exactly match. It's obvious because the duration is a perfect match with itself. Every number is same. If we compare duration with a copy of duration, it is perfectly same. Right. So as this number slightly reduces, 0.9 is not a perfect match, but right, there is this small difference. But you see, the meaning is that if you increase one value, other value will also increase. So you see, the calorie versus duration has that relationship. Duration is here, calorie is here. So calories is 0.9, duration is what I'm checking. So same thing happens if even if you check here, right? So the duration versus calories is having a good correlation. One of them increases means other one will also increase. Right. There is a perfect. So if you say, if at all you see a negative 0.9 somewhere, that means it's also a good relationship, but the relationship is inverse. One increases, other one properly goes down. But if you have a value closer to 0 on the positive side, on the negative side, it means one goes up, does not mean that other one also will go up or down. You cannot determine that. Okay, so normally if you want to say that there is a good correlation, then right, we expect something like anything more than 0.7 is said to be a good correlation, 0.7 or minus 0.7. Okay, let's try to define this limit now so that you can use it at a later stage. So what is a perfect correlation? What is not a perfect correlation, etc. You can see that. So good correlation, bad correlation, etc. can be identified directly over here. All right, then. Okay, now all right, let's go ahead and so that's one of the very helpful part in pandas. Then let's see. Actually, pandas also supports a plotting part. Okay, so Panda actually helps you in plotting, but we may not use this pandas plot everywhere. But let's look at the basics of plotting using plot. All right, so right now, so let's try to plot something. Already we have the data set with us, right? So df is already there, and let me go with the df dot plot. It actually is a very basic type of plot. You can see that, right? This is how the plot looks like. Again, it's a simple plot. I cannot make the modifications, etc. over here because the pandas is not a visualization library, right? You don't have a lot of features available inside this, but still, yes, we can go for the basic what you call uh, basic visualization that are possible over here. Okay, then this is one simple plot, the straightforward plot. Whatever is there, we can try to visualize that over here. But a much sophisticated plotting libraries are available in Python. So we'll be discussing that in tomorrow's session. The upcoming session is all about the plotting, right? We'll see that in that case. But since under Python, whatever, sorry, under the pandas, whatever support we have, right, we will be able to do that over here. We'll be able to check that here. Okay, so the second type of plot that is supported in pandas itself is called as a scatter plot. All right, so this is what we can do here. Scatter plot. So in order to put the scatter plot, the command is df plot. Then you specify the kind, what kind of plot you want. You will say that scatter. Okay, then I need to say what is my x-axis, what is my y-axis. So say that x is equal to calories, and along the y-axis I want to plot duration. So this is the plot. Right, you can also you can actually change this, and we can go for what is called as the next type, which is called as a histogram, right? That's the another plotting supported inside the pandas. All right, so I just have to mention that only I need to change that what kind I want, what kind of plot I want to see. So just change it. So, and you need only one column, right? Because what is the frequency that changes, right? I can actually change it. So for example, I can look at the duration, right? Only the duration column is sufficient to visualize a histogram form. For example, let me show you that. Here, duration itself is what I want to plot. I say the kind should be equal to, histogram is just duration is always around these numbers. Okay, so that's what we have here. Okay, now more than this, I'll give you some important references related to the pandas. And whenever you want to go in depth about the pandas, right, I suggest you to refer to the ones which I'm going to share now, right? So that will help you out in actually looking at much more details about the pandas. And let me show you that. And the one material which I already have shared you, right, that actually gives you a lot of information, that actually has much more information than what I have discussed in this session. But since there's a strict time duration I need to follow for our sessions, right, I'm not able to cover pretty much depth about the pandas. But this much pandas is absolutely important, whatever we have covered. It acts like the basics of the whatever we can study in the upper levels of pandas, or whatever you find in the material which is already shared to you. Okay, so it has much more content. Yes, you should go through that for sure. Okay, but I'll share you some of the materials. I'll share you some links so that you can use it, right, whenever required. And the one is, I'll just write here. This is called as Pandas User Guide. Right? You can access that using this. All right, so this is the one. I'll copy and I'll paste it in our page. Okay, that is Pandas user guide. You can see that it's a very well written documentation for Pandas. So we have right, the complete details about the pandas. You can open and you can check, right, what all you have. There is, right, many more things than what we actually have discussed, right? But the most basic things, etc., we already have covered in pretty much detail. Okay, that's one important reference. Then I'll give another reference. This is called as the API reference of the pandas, right? So it also talks pretty much about each and every objects functions that are actually present inside this part. So actually you can see that inside a series you can go through all these. Everything may not be required for your purpose of learning data science or topics just related to data science, but there is a saying uh, in the data science community that it's very interesting. Somebody truly said that there is nothing in the world which pandas cannot do. Everything, I think, okay, I want to do something like this. Yes, pandas has a solution in it, right? Only we should know where to search, how to search, etc. So basically, we touch only the series and data frame inside pandas. Okay, whenever we teach any level of course, but you see there are many more things to study. You see it's actually too huge, right? So all these things we will not touch that because there may not be that much time required to cover everything. Even if it is a fully fledged course like 3 months 4 months, in that also we'll never cover pandas properly. We'll say that okay, this is where you need to search if you want something. All right, so let me add that here. This is pandas API reference. like that. Okay, so the API reference is pretty much useful, pretty much important, and I suggest you to go through them as and when required. Okay, so I think we have come to the end of Pandas. Okay, and yeah, I will share you the complete document, the codes which we have written today, the documents, as well as the files, the data sets used, etc., and the complete thing, whatever we have covered today, I will share.